Hi everyone, this lesson continues from the place value lesson that you just had. So let's first review what are the base tens. We will start with 10 to the 0 power, which is basically 1 whole because anything to the power of 0 is 1. And 10 to the 1 whole is 10. And 10 to the power of 2 will give you 100. 10 to the power of 3 will give you 1000. Going downward, 10 to the negative 1 will be 1 over 10 or 0.1. 10 to the negative 2 will be 1 over 100 or 0.01. And 10 to the negative 3 will give you 1 over 1000 or 0.001. This pattern should also show you the fact that exponents can never ever get you to 0 or lower, not even negative exponent. Negative exponents will only bring the number close to 0. Okay, now let's get back to topic. What kind of fractions are related to base 10? Let's first begin by knowing what the factors are for some of the base 10s. For some of the base 10s, here's a list for the 10, which are 1, 2, 5, and 10. And here's the list for 100, which are 1, 2, 4, 5, 10, 20, 25, 50, and 100. And here's the list for 1000, 1, 2, 4, 5, 8, 10, 20, 25, 40, 50, 100, 125, 200, 250, 500, and 1000. Given that the list is way too long, if I ask you to memorize all of them, the only thing that you need to memorize is the 10 factors and the 100 factors. The 1000, if you could memorize it, that's great. If not, you can leave it out for now. In this slide, we will go over the fractions that can be converted to decimal easily because it's related to base 10. So an example below, which fractions can be converted to base 10? As you see from the list right here, the only fractions that has a denominator that is related to 10 or 100 is the 5, the 8, and the 10. That means these are the only one that can be converted to a base 10 denominator. For 2/5, you can actually convert it to 10 or 100th by either multiplying by 2, which gives me 4, or timesing it by 20. So you do the same thing right here. That gives you 40. For 3/8, 8 is related to 1000 right here. That means we can only convert this to 1000. So we will turn this into 1000 by multiplying 125 to the 8. So proportionally, we will multiply 3 with the 8, and that brings 375. The next one is 5/10, and as you can see, 5/10 itself is already in base 10, so we don't need to change anything. When they're in base 10, they're super easy to convert to decimals, which is all about the denominator. This is the 100th. So it will be 2 place values from the decimal point, and we fill in the numbers backward. So there's a 0 here, there's the 4 here, and for the 1000th, it's 3 place values away from the decimal point, and you start filling them in backward. The last one is 5/10, which is only 1 place value from the decimal, so you only need 1 line, and you will put in the 5. Now in this last slide, the title says, is it possible? The first example given is to ask you to find decimals in between 5/10 and 6/10. Notice how they're right next to each other. Is it really possible to find a decimal in between them? The answer is yes, but we need to tweak it a little bit first. 5/10 and 6/10. Do you know that you can add a 0 at the end and turn it into 50/100th, and this one into 60/100th? And guess what? Now you just created a gap of 10 numbers in between them. And one of them will be 0.51, 0.52, and so on. If you want to go even further, you can also turn this into 500,000 and 600,000, and you have just created a 100 number in between them. And in this next example, you can do the same thing. To find numbers in between 45,000th and 46,000th, all you need is put a 0 at the end of the two numbers, and now you have just created yourself 10 numbers in between them, which one of them will be 0.0451, and so on. So to wrap this up, all you need is to expand the decimal by placing a 0 to the end of it. That's it for the lesson.